In Activity 12, Magnets in Space, students first view and discuss a video of magnets being handled in space by astronauts on the space shuttle. Students then observe the interactions of magnets on Earth and in space, and finally formulate their own questions about the magnets. You will need the following materials from the kit: wooden dowel, ring magnets, magnetic marbles, marker, and the Magnets in Space videotape. You will also need to provide metric ruler and a VCR and monitor. To prepare for the activity, mark the magnetic marbles for a demonstration. Put the 12 marbles in the groove of the plastic ruler, allowing them to form a chain. The poles of the marbles are where the marbles touch. Use a permanent marker to mark one pole of each marble. Bring the wooden dowel, ring magnets, and the magnetic marbles to your demonstration area. To begin the activity, invite the students to gather around your demonstration area and tell them that you have some new magnets for them to look at. Show them the magnetic marbles and ask, "What do you think will happen if I let all these magnetic marbles roll together? What shapes will they form?" Listen to the students' responses and then roll the marbles together so they form various shapes, such as a caterpillar or a pyramid. Try making the marbles dance on the table without touching them. Next, show the students the wooden dowel and the ring magnets. Ask students, "How could I arrange these magnets so that they seem to float on the dowel?" Give students a chance to offer suggestions. Then place the magnets on the dowel so that each additional ring magnet repels the one before it. To do this, the like poles of the ring magnets must face one another. Next, explain to students that on Earth, more than just magnetic force affects the behavior of a magnet. Gravity and Earth's magnetic field both slightly change a magnet's behavior. Remind them of how all their rod magnets pointed in the same direction when suspended by strings. Tell the students that in a spaceship orbiting the Earth, objects and even people can float. This condition is known as microgravity. Show a video of astronauts investigating magnets to see how they behave in microgravity. Make sure that the students notice how the magnetic marbles form a short chain that begins pivoting around its center. By the 7th marble, the chain forms a circle. Additional marbles are absorbed into the circle. The video also shows an astronaut investigating how two 6-marble circles interact. The astronauts also investigate the behavior of ring magnets on a dowel. Bring the students' attention to the ring magnets and how they respond when the astronaut compresses and releases them on the dowel. Then remind them of how the ring magnets behaved in class. Explain that on Earth, magnetic attraction and repulsion is affected by Earth's gravitational pull and Earth's magnetic field. In space, the magnetic forces of the magnets themselves dominate the motions of the magnets. The magnets are free to float. Next, put the magnetic marbles, the dowel, and the ring magnets someplace where students will have easy access to them. Have each team carefully write a question regarding the magnetic marbles or the dowel and ring magnets. Then have them try to answer that question based on what they observe by working with the magnets. Finally, invite students to state their question and the answer they came up with from their experiments with the magnets. Ask students, which rules of magnetism were illustrated by your study? Students should be able to recount several rules of magnetism, such as all magnets have 2 poles, magnetic force is strongest at the poles, unlike poles attract and like poles repel. To conclude the activity, return the videotape to the kit. If possible, leave all the kit magnets where students can investigate them during free time. When the time comes to put the magnets away, be sure to store them with their unlike poles together. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.